Welcome to Saxon Math, Course 3, Lesson 115, Relative Sizes of Sides and Angles of a Triangle. Now, important thing to remember is a large angle makes a large line, and a small angle makes a small line. And what I mean by that is if we have equal sides forming an angle, then the line that connects those two lines, this one here, and this one here, will have its size determined only by the angle of the lines which connect them. So this angle here decides how long that line is, and this angle here decides how long this line is. This is part of the reason why an isosceles triangle has equivalent angles on its bottom portion, right here and here, creating equally long sides, here and here. Now, when we look at triangles, we can compare different angle sizes using different sized triangles. We can use their angles and their sides to compare between triangles. So, if we're looking at this triangle here, we have three sides. Now, of these three sides, each one is connected to an angle. The smallest of these three angles is angle A. Now, angle A creates side BC. Angle A is the smallest angle, and it creates side BC, the smallest side. The next largest angle is angle B. Now, angle B goes up and creates angle A, a side AC. The largest angle, which in this case is actually a right angle, is angle C. Angle C creates the line AB. And since it is the largest angle, it creates the longest side. This is part of why the hypotenuse, the longest side, is always across from the right angle in a right triangle. Because in a right triangle, a triangle with one angle that is 90 degrees, the 90-degree angle will always be the largest angle. So the side it creates, the side across from it, is always the longest side. Now, example 1 asks us to list the sides of this triangle in order from shortest to longest. And it gives us two angles. Now, it gives us a 59 right here and a 61. Now, if we add those together, we get 120, which, if subtracted from 180, will give us 60 as this side here. Now, in order to list these sides in order from shortest to longest, we first need to know the angles. So we have R is 59, P is 60, and Q is 61. Now, P is across from line RQ. R is across from line PQ. And Q is across from line RP. That means that since we go down in this order from smallest to largest, this order is smallest to largest for sides. So in order, it would be PQ, then RQ, then RP. Now, a good thing to remember, to notice here, in order to be able to check your work later on, is the angle that creates a side, its letter is never included in the side it creates. So if you notice, Q creates side PR. R creates side PQ. P creates side RQ. The side that an angle creates in a triangle is labeled with the two letters that are not that angle. This is useful in diagrams which only contain one triangle. As we get to diagrams which have other shapes in them as well, you might need to use a three-letter name of an angle, in which case the side it created, if we can call angle P angle RPQ, which is the angle which goes from R to P and then to Q. R, P, Q. You can see that that's the same as angle P. Now notice, angle RPQ creates side RQ, because it is the two endpoints which are not the vertex of the angle in a triangle. In example 2, we are told that the lengths of triangle ABC are given and are asked to list the angles in order of size from smallest to largest. So, we are given that AB is 7, CB is 8, AC is 9. So, first we're going to order those side lengths by length. So, 7, then 8, then 9. 7 was AB, 8 was BC, 9 was CA. And then all we have to do is say which angle creates AB. Well, that angle is angle C. So we're going to have angle C is less than which angle creates the 8. Well, we just go across from it. The angle across from it is angle A, which is less than the angle which creates the 9, which is angle B. And that's all you have to do. For example 3, we were asked, if we know the side lengths of AC, can we find the side length of WY? Find WY if AC is 6 centimeters. Now, in this triangle, you're given 2 pieces of data, or 3, about each triangle. Now, you're given 2 angle measures and 1 side length. 2 angle measures and 1 side length. Now, since these 2 angle measures don't necessarily match up, we need to make sure that they do, because we have one pair which are exactly the same, 85 and 85. And now we have to check, is 85 and 40 going to give me 55? And will 85 and 55 give me 40? So if we say that A plus 40 plus 85 equals 180, then we will get A plus 125 equals 180. If we subtract 125 from both sides, we will get that A equals 55. If we have 55 plus X here equaling, or plus 85 equaling 180, we'd get X plus 140 equals 180. And when we subtract 140, we would get X equals 40. Since these angles are the same, if we have angle, angle, angle similarity, that means that we can create a proportion between the 2 triangle side lengths. Now, what that means, the side which matches up with the 85 in this one is the same corresponding side as the one which matches up with the 85 in the other triangle. So that means that we can take AB, which is 8, and WX, which is 6, and put them on top in our proportion. Similarly, if we're given AC, which is the line across from angle 40, And asked to find WY, the line across from the angle 40, we can put 6 and x on the bottom. Now, there is not an easy horizontal rule. 8 does not multiply to become 6. 6 does not multiply to become 8. There's not an easy vertical rule, again, because it's the same numbers. So what we'll do is we'll use the diagonal rule, cross multiplication. And we'll say that x times 8 equals 6 times 6. That will mean 8x equals 36. And if you divide both of these by 8, you'll get x equals, well, if you think about it, 8 would multiply by 4 to give you 32, and 36 is 4 more than 32, which is half of 8. So we can say that x equals 4.5, because it's 4 times 8 plus half of 8. And we found WY. That's how you would use similar triangles relationships, knowing that their angles are the same, knowing that the sides which are formed by a same angle will have a proportional relationship to another triangle's side. Now, this has been lesson 115 of Saxon Math Course 3. Make sure you study hard, do your homework, stay safe, stay inside, and wash your hands.